This is Graham's classes. You're doing it on the paper. You're starting with the chart on the bottom. With my class, you're actually starting with question number 2. And after giving with question number 2, you got a few minutes because it's going to wait until water. But when we start writing in our typing in your observations, you're going to go, my class, just start with 2 and then you go 1, 3. Sorry. I do that stuff just to keep you on your toes. Alright. Every time I do one of these demos, or I'm doing something, I have my test tubes and my beakers labeled. These are the copper and hydrochloric acid. Here's zinc and hydrochloric acid. Calcium and hydrochloric acid and magnesium here in a few minutes. Alright. Transition metals. They're important to our lives. You know, we use them every day. But as far as reactivity goes, alrighty, here goes the copper and hydrochloric acid. Anything exciting? What did it do? Oh, it did something.
It rose.
It rose?
Gain in volume.
It sunk. There you go. It sunk. As I dropped it in, it sank. Any bubbles? Any color changing? Any gas being formed? No, it just sank. Yes. Hey, here is zinc. Guys, in my class, I left off the hydrochloric acid one, so you're don't get too excited here. Just watch. All right, so now I did zinc and hydrochloric acid. Again, where did it go? It sank. We're not seeing any bubbles forming. We're not getting any color changes. No, there's not a temperature change. It's just not even exciting at all, is it? No. Back there, Xander's like, oh my goodness, it's Christmas. Come on, move on to the good stuff. Don't blame you, Xander.
Yeah.
All right, I'm going to put these off the side. Now, they are reacting with the hydrochloric acid. They're just reacting very slowly. As a matter of fact, since y'all are 7th period, I'm not going to empty out the test tubes after 7th period today. I'm just going to kind of leave them in the rack. And then we'll watch this for the next few days. Copper will probably dissolve in about 2 to 3 days. This is how long it typically takes. And honestly, I don't know how long it takes the zinc. Because the zinc is one of those things that I'll check on it, and I'll check on it, and then I'll forget about it, and then I'll check on it again, and I'll look up one day, and I'm like, wow, it finally all dissolved. And it always seems to do it on a weekend, too. Right. It will eventually dissolve in the hydrochloric acid. Alright. So let's move on to something that'll be a little bit more fun. What do y'all remember what we talked about last week when we talked about the properties of the periodic table? What was one of the properties of group 1 and group 2? They were very reactive. So, transition metals, they didn't have that characteristic. Our transition metal, our group 1 and group 2 metals do. So, let's start off with some magnesium. Probably do this in the right way.
Let's see what this one.
Okay, where is magnesium on the periodic table? Where's magnesium? It's MG. Okay, it's row 3. It's in the 3rd period. And column 2. So, it's got the atomic number of 12. I'm putting it in the one labeled magnesium. And what happens if I put magnesium in the...
It makes gas. It's already... It's evaporating.
It's slowly kind of starting to kind of react with the hydrochloric acid. We start to see a lot more bubbles now. And it's kind of hard to see on the screen here. But even down here in the test tube, it's still kind of hard to see. Oh, by the way, don't forget goggles. Everybody should have their goggles on. Not. Yeah. Yes. It's not real exciting, but it is definitely reacting with the hydrochloric acid. Definitely got a bubble stream going now. Look at all the bubbles now. Now it's no longer clear liquid in there. And it's not that the water's changed different colors, it's just there's a lot of gas bubbles in there. So it's kind of got that off-white looking color. Alright, we're going to let that finish while we talk about some calcium.
Calcium. It's going down here. Is it going to explode?
Well, let's see here. Now, calcium, where is calcium on the periodic chart compared to magnesium?
Directly underneath magnesium.
Well, I like your answer, Xander, directly underneath. What was one of the characteristics of our group 1 and group 2 metals? Were they hard? Soft? Yeah, one of the, so I've got a chunk of calcium here. And it's just a piece of gray metal. Yeah, I guess he's really not all that exciting. But if I sit here, I can cut him in half with my hammer. Anyway, with my hammer and my screwdriver. So, on a scale of 1 to 10, scale of 1 to 10, what would you say my effort level was to cut the calcium in half?
3.
I'd say like a 3.
We're going to say make 10 the hardest and 1 the easiest.
2.
I'd take a hammer and a screwdriver. I mean, if I take the hammer and screwdriver to this card here, am I going to knock it apart?
No.
No, so it's probably not a 10, but I did take a hammer and a screwdriver, so are we really going to call it a 2?
5. 3.
Yeah, I like the 5. Let's call it a 5. We'll put it right in the middle. We'll call it a 5. Alright, I'm going to put this piece right here for now. Bring back the hydrochloric acid. But y'all ready? You gotta be watching, because you may end up missing. This is calcium and the hydrochloric acid. When I put the calcium and the hydrochloric acid,
Oh boy.
you can see it kind of bouncing around down here, and he is kind of bouncing around. Yeah, he's just a little bit. So he's kind of hard to see down there because of the bend in the glass. But notice what's happening to the water. The color of the water. It was really, really clear, and we're starting to look a lot like our magnesium water over here, aren't we? And you can see the bubbles escaping here at the top. So even though it was kind of hard to see the piece of calcium down there on the bottom, it was reacting with the hydrochloric acid. And matter of fact, as it's reacting with the hydrochloric acid, it's breaking the HCl into 2. The calcium is reacting with the chlorine, making calcium chloride, and the hydrogen gas that used to be part of the hydrogen chloride is escaping out of the top of the test tube. And this one right here, somebody remind me at the end of our little demo here to come back and show you the hydrogen chloride and calcium one. There'll be a nice precipitate. Ooh, there's a new word for you guys. Precipitate. What does precipitate sound like? It sounds like precipitation. What is precipitation?
Rain.
Rain. So it's something falling out of the sky, right? Because technically, precipitation is rain, snow, sleet, all those things, right? Hail. So precipitation falls out of the sky. If I have a precipitate in my solution here, what do you think a precipitate is? What do you think?
A little drop from the top or something?
Yeah, it's something that comes out of solution and it settles on the bottom. And this is actually making a really, really nice white precipitate.
Whoa.
Alright, I'm going to move myself to the side. Let's move into something a little more dangerous than hydrochloric acid.
Oh, yay.
Like what? Vinegar, sulfuric acid?
Like what? Are we working with water?
How about water? Remember the whole campaign to ban water because it was awful?
And it's
It wasn't water, it was... Oh, I heard about that. Wait, what?
dihydrogen.
Dihydrogen monoxide, that's water.
Oh, let's get the goggles on. I get a feeling this might just cause a big... I get the feeling the Big Bang Theory will repeat itself.
Alright. Alright, so I've got my beaker. It's labeled, this time it's labeled magnesium and H2O. I'm going to add a little bit of cabbage juice. Cabbage juice is just an acid-base indicator. And we use it to help us identify if we have an acid or if we have a base. Nice thing about cabbage juice is it works both for acids and bases. There's some indicators out there that will only tell you if you have a base, or they'll only tell you if you have an acid. Cabbage juice will tell me it works for both of them. It's blue, like it is here, when it's neutral or has a pH of 7. And we hope that our drinking water has a pH of 7. We want it to be neutral. And if it was acidic, it would turn pink. And if it was basic, it turns yellow or green. Here, I'll even give you a little, since you're my last class. Here's the hydrochloric acid that I've been using all day. Notice right now, it is clear. I put in the blue cabbage juice.
Is it red?
And yeah, it turns a nice pinkish red. So for acids, it'll turn pink. For bases, it turns more of a yellow, and then sometimes even a green. Alright, so let's see here. Magnesium and water. Well, magnesium and hydrochloric acid, how did it react?
It dissolved.
Did it dissolve quickly?
No.
Yeah, it kind of took a little bit. Guess what? Magnesium and water. What do you think? Y'all say anything?
Yes.
What did it do?
Is that still good?
Oh, it didn't do nothing. What did it do?
It sank.
Yeah, it sank. See it down here on the bottom? See any bubbles forming around it? See any bubbles on the top of the water? Color change?
Not really.
No, not really. Okay. Once again, in all honesty, yes, there is a reaction going on, but it is happening so slowly, you will have grandchildren before we probably see what's going on. So, I'm just going to put this one back over here. Let's go to calcium. Now, when I put calcium in hydrochloric acid, how did it act?
It bounced around and slowly bubbled.
I was saying, it bubbled, but did the bubbles form faster or slower?
Slowly turning milk.
Technically, they actually formed faster, but I think your case, yeah, there was something not. All the other ones today that did what it was supposed to, and the calcium didn't actually make bubbles faster. Alright, so my calcium beaker, I'm going to get ready. I'm going to put a little more cabbage juice in here again. Make my water all nice and pretty blue. Make it nice blue. Don't make it too blue because then we can't see the metals in it. Alright, so I'm going to take a piece of calcium. And I'll drop calcium in the water. And yeah, it's making bubbles. You can kind of see it. It's making some bubbles. It's starting. You see how it's kind of moving and wiggling down here? That's the hydrogen gas bubbles forming on it. And of course, where does the hydrogen gas want to go?
Up.
Yeah, it wants to come on up. You see lots of bubbles forming now. So would you say that calcium in the water was a little more reactive than the magnesium? Yeah, definitely more reactive in the water. It was more reactive in the hydrochloric acid too. I'm just not really sure exactly why it didn't bubble up, because all day long it's been making bubbles like right away. I'm going to blame it on the camera, because the camera, it's a good camera, but it's supposed to be recording pretty well, but yeah, it's got a little bit slower focus or something. Alright, anything happening to the color of the water as that calcium is bouncing around in there? I say it's not looking as blue anymore, is it? Yeah, it's kind of turning more, because remember, here's the color blue we started out with.
Oh yeah, it's definitely more green. It's like a turquoise.
Yeah, kind of more turquoise.
Yeah, it's greeny.
Yeah, it's kind of getting greener and greener and greener, isn't it? Here, I'll set that one over there. Now it's barely in the picture. Yeah, this is calcium and water. That's the magnesium and water. Nice and blue. Let's say nice and blue. Kind of green up. Almost looks like icky pool water now, doesn't it?
Gee, I don't want to go swimming in that.
Yeah, so I'm thinking I don't want to go swimming in there. All right. Well, let's get out of the alky earth metals and let's go to my favorite group. Group 1. What's the name of group 1?
Alkaline metals.
Yeah, the alkaline metals.
What's
Okay,
next?
alkaline metals. How many valence electrons do alkaline metals have? One valence. How many valence electrons do alkaline earth metals have? 2. So if I have one less electron, who has an easier job of getting rid of those electrons and getting back to a full shell?
Alkaline.
Yeah, the alky metals do.
I have no idea. What's this one?
I can't see them in the dark.
What is it? Sodium? I hope it's sodium. Please be sodium. Please be sodium. Please be sodium.
Oh.
If it's sodium.
So we don't have any, well, we have hydrogen gas, but that's not a solid. What's the first metal in the alky metal family?
Lithium.
Lithium. What's one of the properties of the metals in the lithium family? Remember, calcium I cut with the hammer and screwdriver. So, are they still supposed to be soft? Yeah, they have kind of low densities. They're soft, easy to cut. Guess I grab a big old chunk of lithium here. Plastic knife from the cafeteria.
At the end of the day, don't cut it.
I can't see.
Plastic knife. Cutting it. I gave up. I'm going to go ahead and use my little metal knife here. But if I take this metal knife to the cart over there, am I going to cut the legs off? Yeah. There we go. I could have got it with the plastic knife. It just was going to take too much work. Too much work.
What are you doing? Screwdriver and hammer again?
No, I just used a metal knife. Metal knife. All right. Alright, so lithium, I'm moving one group to the left from where we were. And we always tell you that these guys are even more reactive. Remember, they're not found in nature by themselves because they like to bond with other elements. What do you think? It's going to react quickly, slowly.
Quickly.
Fire in the hole.
Wow, check that out. Where is it?
It's floating.
It's floating. Did it even sink at all?
No.
Lithium.
Water and cabbage.
Yeah, this is just water. Lithium has such a low density, it floats. It's floating in the oil in this jar. And if oil floats on water, where do you think lithium's going to be?
On the top.
Yeah, it stays up there on top because it has a very, very low density.
The smell of lithium on water, I have to be careful.
What's happening to change the color of our water?
Very green.
Yeah, it's very green, isn't it? Well,
That's basic, all right?
Yeah, it's very basic. I'll move it over just a little bit. There's your original blue color, and it's going green. Now you need to have your goggles on, not on your forehead. Can't protect your eyes if they're on your forehead.
What if you have glasses?
Just put them on over your glasses.
I can't see.
Alright. What element is below lithium?
Sodium. Yeah, but that water. Alright, now we're going to need to cover our ears. Yeah.
Alright.
Flows.
So, as we go down with the time they get more reactive, what do you think about cutting this piece of metal? Sodium I had to use, calcium I had to use the knife and the screwdriver. Lithium, I could use the plastic knife. I gave up though because it was a big piece and I used the metal knife. What do you think about sodium? Easier or harder for me to cut?
Harder.
So yeah, this time I really am going to stick with the plastic one. Watch how easy it is to cut this one. I can stay still.
Ta-da! Metal cut like butter. Or
Yeah,
metal cut like cheese.
more like a piece
rather.
of cheese, yeah.
Bang. Metal
Yeah.
cut like cheese.
Some kids today have asked me, well, it cuts so easy. Is it kind of like putty? Well, I can kind of squish it and mash it around. It's a little bit, I got to put a little effort into it. Oh, I know. Well, at least this one you can actually. It says I'm recording. Hold on.
You're recording the whole day
No, it's just one.
for each class?
Just this one. I thought I was recording last period. It turned out I wasn't. All right.
Oh.
So here we go. I've got some very blue water. I've got one smashed up piece of sodium metal. Y'all better be watching because otherwise you're going to miss the fun. Okay, do you think more reactive or less reactive?
A lot more.
More reactive because you're
More reactive. Oh, yeah.
Yeah, I'd say it's a little more reactive.
It looks like I took my hand.
It's so green. It's so
What's
green.
going on? Is it flying?
It's very dark if it doesn't.
So let me catch on fire all day. I will.
Sooner or later it's going to explode, isn't it?
Alright, all day long it's not on fire. This one's very
Sodium.
I don't want to catch on fire.
They can catch on fire.
It's disintegrating.
Dissolving? Yes.
Hey, bonus.
So water sets it on fire.
Did I get a color change in my water?
Yeah, that looks like orange green.
Even though it didn't catch on fire for me like I was hoping it would.
Wait,
Maybe you're not the
I
way.
saw a shark. Sparkling.
Did it spark up a little?
Yeah.
But it didn't catch on fire.
Try again.
That's turning red.
Or put twice as much in.
Teacher, please release the 7th grade C team. Release the 7th grade C team.
Alright, bonus. Let's
What
try it
did
one more
Mayor
time.
say this time?
Is that red?
Alright. Not putting any cabbage juice in this time. I'm just leaving it white.
Did it turn red? Gotta be safe in the lab.
Fireball!
Oh boy.
Whoa. Is this a
be a fire in the hole.
Is this a different metal?
I got fire that time.
Guys, it's not smoke, it's just gas. It's hydrogen gas. Same stuff you breathe. It's okay. But it's the same stuff.
I wonder, it's Christmas, was the camera there during the explosion? Look what that again!
Hey, I hope you're all writing your observations right now.
Okay, I got one more to go.
Okay, we're not done yet.
I gotta make this one better than that last one. Alright, potassium.
Potassium.
Anybody remember what I was looking for?
Fire in the hole, let's hope this one blows. Get over with. Okay?
Hey, guys, seriously. I know it's kind of exciting. That was sodium. Y'all got a bonus. The first sodium didn't catch on fire. I put another one in there. He caught on fire and he popped. What's below sodium on the periodic table?
Potassium.
Potassium.
Okay.
Yeah, it should be more reactive. Yeah. Keep in mind, I don't really want to blow up the school. What do you think's going to happen with the potassium? Easy to cut? Hard to cut?
Should be as easy as cutting melted cheese.
This is like Xander's melted butter.
Yeah.
That's terrible. Mission accomplished.
Well, if it wasn't,
God wasn't so happy with the amount because you could see, especially after it was pulled out.
Guys, are we done? Should we just be done? Are you also listening? It smells bad. It doesn't smell like anything. It does.
Hey,
smells like
Austin, what?
What was the chemical that blew up?
That was sodium.
okay.
Alright, so now I got a piece of potassium. Cut like butter. Man, you want to talk about moves like putty. And this one really... No. You see me holding this stuff? Alright. What do you think? More reactive, less reactive? Now, I have to admit, part of this has to do with size. Think about the first piece of sodium. Compare it to the first piece of sodium because I wanted to make it go boom. I put a big piece of sodium in the second time. So, in your minds, when you're comparing this, compare it to the second piece of sodium.
Yeah, I hope it's more reactive, more like a second.
Okay. Oh. Oh my god. Oh my god. Firework. Oh my god.
Fire in the hole! done.
I thought
No more pots.
So, what do you think about potassium?
the sodium.
More reactive or less reactive?
More reactive. It's not.
Say yeah. How long did it take for potassium to catch on fire?
A few seconds.
Yeah. How long did it take sodium to catch on fire?
Like right when it
30
got in.
seconds.
So yeah, even the second piece where I kind of, made a big one and mushed it out, it didn't just catch on fire right. It reacted with the water right away and started fizzing, but it didn't catch on fire. That potassium will catch on fire just about as fast as it falls in there. Notice I didn't stand next to it. There's a reason why I'm not standing next to it. Because I don't want it, doing all that stuff on me.
That's also an example of fog.
Alright, yeah, this is just a nice collection of hydrogen gas in this piece. And now I'll just let the vents take the hydrogen gas and pump it out into the environment. And it'll go into space because it's so light that where's it going to go? Up. And yeah.
I was gonna say that. I wish that
Wait, did the water change color or was it already in my water?
Oh, yeah, I forgot to put the color.
Still blowing up.
Oh my god!
The fish! Artificial paint! No, they're all dead. They're swimming.
I just hope my voice.
Apparently they think you're recording it.
None of pilots.
Okay?
Yeah.